Hello once again, our most developed student. My name is Confident and welcome to our revision session. This is a previous grade 11 paper and I'm looking here at analytical geometry part, and I saw this as a good question just to prepare for your exams, whether you're writing your June or you are writing your November exams, and these guys is gonna come handy. Look at this question number 1. It say here, as I said, it says here, question 1.1, the points D, E, and F are vertices of triangle DEF. So they gave us the coordinates there. Now it says determine the following. Now I want to make it clear to say in your grade 11, they don't give you the formulas, guys. You need to have your formulas in your head. The funny part is you will be given the formulas in grade 12, but in grade 11, no. So I will encourage you, always remind yourself of the formulas. And whenever we are dealing with what? Analytical geometry, one thing I will bring is these common formulas. The first one is your gradient. M, remember how to find it? It's y2 minus y1 over x2 minus x1. This is your gradient. Very important. You definitely need to know that. And then secondly, it's your what? It's your I'll call it the distance formula. The distance is square root of x2 minus x1 what squared plus y2 minus y1 squared. But everything is under the what? The square root. That is the distance formula. And then you have got the midpoint formula where it's m. So what is your m? Midpoint, it's x1 plus x2. These are the coordinates of the midpoint divided by 2. And then you've got y1 plus y2, you divide by 2. You definitely need to know this. And lastly, you've got what? The equation of a straight line. There are two of them. You've got y is equal to mx plus c. I prefer this one, but there is the other one, which is y minus y1, which is equal to mx minus x1. Guys, these need definitely you need to have these handy. These will be kind of, that's why they allow you to get more practice of these in your grade 11, grade 12. Yes, the formulas are given, but you can even apply them without looking at the formula. Let's look at this question. 1.1.1 says the gradient, you see, of DF. So you look at D, let me write the coordinates of D and F. So here you look at D as minus 1 and 2, and F as minus 5 and what? Negative 3. You can even try it while I'm working on it like this. Also, give yourself a try, because I know it's not very complicated here. Most of you only make errors. That's why I want to show you where is the common error. So now, when you're looking at it like this, remember the formula says what? There is the formula for gradient m. So if you're saying here m of df, meaning gradient of df, so I can choose now to make this is my x, this is my x. See, this is my y, this is my y. That's how you do it. Put a 1 here, this becomes a 2. Put a 1 here, this becomes a 2. So it says y2, which is minus 3. Let me maintain my, so it's minus 3. That's where my y2 is. And then minus y1. Minus y1 is 2 over x2 is minus 5. That's where now most of you will make an error. It's x2 minus x1. It's minus 5, and then there is minus of the formula, and again there is a minus 1. You see, then you put brackets there. That's where it will just make it a little bit complicated. It is those two negatives. Once you master those, then you're good to go. Your calculator will come handy. Negative 3 minus 2 over negative 5 minus bracket negative 1. See that? Actually, I'm doing this wrong. Go down. It's -5 minus bracket -1. Right, then what's the gradient? According to this one, it is it's positive 5/4. So that is 5/4. That's the first answer there, which is what? The gradient of df. So let's write it there. We might need these answers. 5/4. So that's the gradient of df. And then they're saying if line DE is perpendicular to df. So when they talk about perpendicular, they're saying these lines, what do? When you've got DE, I don't know how it looks, and you've got let's say this was DE. I'm just giving an example. If DE is perpendicular to DF, now DF, it will be something like this. Okay, not like that. DF maybe will start from there since D is involved. So you'll have like F now. Perpendicular means they meet at what? At 90 degrees. But let's come to, let's have a little bit of a reality here, and then have like our Cartesian plane just as an example to say how was it going to look like. So remember, this is your x, this is your y. So we are saying D is -1 and 2, so it's somewhere there. That's your D. It's just a sketch. And then E is 4 and 4 and -2. Let's say E somewhere there. And then F is -5 and then what? -3. Maybe F is somewhere here. You see? So they are saying DE, there is D and E. So here they are saying if DE is perpendicular to what? To DF. So that's where now, okay, let me do it procedure like here. If I'm drawing this, there it is. So I expect now here to be my point what? To be my point F. And then there is the 90 degrees I'm talking about. You see that? That's the perpendicular part. I see. So I'm just going to try to maintain it like that as these points, but I'm going to erase just in between just to see. I'm just going to maintain my sketch like this. Alright, I'll continue the line. Just want you to see here, but we'll continue this. Now it says if DE is perpendicular to DF, and then write down the gradient of what? DE. Now look at this. It's a very common one again. We know the gradient of DF, and then there is a formula which says, I didn't write it here, for gradients. I'll do this. For gradient, if lines are parallel, so if you say parallel lines, the gradient is M1 is equal to M2. For perpendicular lines, perpendicular, it says for perpendicular lines, M1 times M2, you get a -1. That is for perpendicular lines. So here, if I know the gradient, which is M of DF is equal to 5/4, but there is a formula which says M1 times M2 is equal to -1. So I can say now M of DF times M of DE. It must give me -1. Remember what they said here. If the line D is perpendicular to DF, write down the gradient of DE. So we want the gradient of DE. We know what is the gradient of DF, so it will be 5/4 times gradient of DE. See that? It's -1. Then it's up to you how to do it here, but the easier one is to multiply by the inverse of that, which is 4/5. But what you do on the left, you do on the right, 4/5. So if you do that, you have got that cancels, M of DE equal to negative what? 4/5. So now that becomes the answer. So in simpler ways, how can you just get this answer? If I know M of DF is perpendicular, that's how you write it, is perpendicular to m of dE. So what I need is to know the gradients. Now I know the gradient here is 5/4. Now if it's perpendicular, you must know then that the other gradient you invert, take this to the side, it's an inverse, so it's 4/5, and then you put a negative. That's why they say to write down. You can literally write it down. So it's minus 4 here. It's what? It's minus 4/5. That's the gradient. Alright, and then 1.1.3 says we're here now. The equation of the line DE in the form of this. They want if the line DE is perpendicular north south. So now they want that equation of the line DE. So if they want the equation of the line DE, what you need, you take any point, you can choose D or you can choose E. Let me just choose D. I know the gradient, remember? So let me use D as minus 1, 2 here. D being minus 1, 2. Now remember the equation of a line, we did say I prefer to use the first one, y is equal to mx plus c. So what I do here, I'll say y is mx plus c. Remember I know the gradient of dE. That is what they're talking about. They want the equation of dE. So knowing that, I know that I've got my x here on point D, and then I've got my y. So I substitute now to say y is what? 2 is equal to m. Remember I know the gradient that it is, which is minus 4/5. X I have from the D there is minus 1, and this equation allows me to get c first. Do you see that? Then 2 is equal to now negative and negative is positive 4/5, because I'm multiplying there, this will cancel out, plus c. Then I'm able to what? To take this to the other side. It will be 2 minus 4/5. Then it give me c. Then I can use my calculator easy there to say what is 2 minus 4/5. I don't know whether this thing, guys, is making sense, which is 6/5. So c is equal to 6/5. Then when you're writing your final answer, it will be what? Y, because it could be y is equal to mx plus c. So y is equal to minus 4/5, which is my m, and then you always write y and x, and then c now becomes 6/5. This is the answer. Should we have wanted to use this formula, this one, y minus y1 x, let's use it also just for interest sake, to say if you wanted to use, let me keep it there. Let's say you wanted to use y minus y1 is mx minus x1. Sometimes I use this one to check my answers. I know my y. Now this is what happens, guys. This becomes my x1 in this case. This becomes my y1 in this equation. So it will be y minus y1, which is 2. You see there is the 2 there. I'm saying that is equal to m. Don't forget we had our m there, which is negative 4/5. Bracket x, you remain with x, minus x1. Now look, minus and minus 1. You see that? So when you see these two, they will become what? A positive. So you have got y minus 2 is equal to minus 4/5. I know you're like, but you can't put it like that. It's not really wrong. I know you must put a bracket inside like that, but even if you leave it out like this, it's still fine. But the important part is to tell us it's x plus 1 later. Here, that's where now you need to know your way of solving. Open this bracket here. So you've got y minus 2 is equal to minus 4/5 x, and then 1 times that is minus 4/5. Then take negative 2 to the other side to join negative 4/5. It's y is equal to negative 4/5x, and then you've got minus 4/5. Negative 2 becomes plus 2. You see that? And then you finalize your answer, which is y is equal to minus 4/5x, And then if you remember, we did also get this to say what is 2 minus 4 over 5. It's the same thing here. So it will be what? It will be plus 6 over 5 if I did it right. So the answer will still be the same as the one that we got here. Minus 4 over 5x plus 6 over 5. Alright, so that is that, guys. So that was your 1.3. Now 1.1.4 says the equation of the line parallel to DE passing through the point F in the form y equal to. Now let's look at this. The equation of the line parallel, you see, they need such. They will be testing you on such. Now first it was what? Perpendicular. After perpendicular, what do they bring to you? They bring to you the word parallel. Parallel to what? DE, but passing through point F. So if I bring my point back, you said somewhere here, it was something like this. And somewhere here, we had our point F. Remember that. So now they are saying there is a line that will pass through point F. But it must be parallel. It's more like you've got something like this. I think that, but I want it to pass through this point like this. Yes. So when they say it's parallel, it's like you've got these lines, you know. So now you come back to that concept to say, number one, it passes through point F, meaning you need to know the coordinates of F. F is minus 5 minus 3. So remember we're doing question 1.1.4. So let me write this 1.1.4. So F is minus 5 minus 3. Am I right? Let me just check again and confirm my F. It is minus 5 minus 3, which is correct. But guess what? They said it is parallel to DE. Look at this. Parallel to what? To DE. But we know the gradient of DE. Come back here and say, what is the gradient of DE? M of DE was what? Minus 4 over 5. So you continue with that to say, okay, I know the M of DE is equal to minus 4 over 5. So for you to find the equation of a line, again, you just need that point and the gradient. Use the formula, the one that I said I prefer, which is what? Y is equation of a line. Choose any, mx plus c. I prefer this one. That's where I now choose my x and my y, just like the previous method. Alright, so it will become y, which is negative 3, is equal to m. So this one allows me to find c, which is minus 4 over 5. X is what? There is minus 5. And then plus c. Then at this stage, I have to simplify. 5 cancels 5 to give me a 1 there. But negative is positive. So the answer is minus 3 is equal to what? So if this becomes positive, it's positive 4 plus c. I think that. Then how do I find c? Take 4 to the other side is positive, it will become negative. I think that. So I will have what? Minus 3 minus 4 is equal to c. So minus 7 equal to c. So when I'm writing now my equation, it is going to be y is equal to m, which was minus 4 over 5, that mx, c, which is plus c, which is negative 7. You can try it with this one. Y minus y1 is equal to m x minus x1. Try this one. It must give us back the same answer here, but it's a good point for you to test it and see if it does that. Alright, but I'll move on. The next question here, so it's 3 marks. The next question says, if G 6y is a point on DE. So along here, let me complete this line again. DE, you know, along here there is a point they call G. Now G is the x value is 6. Remember, E, let me do E is what? E was 4 negative 2. Alright, So obviously they are saying this can extend further, like it can stretch further like this, and then you'll have a point G, which is now X is 6 somewhere here. You can have your G, because you see 4, so obviously it's after 4. And then is a point on E, determine the value of Y. You see now, so the whole, look at the marks, is 2 marks. So they want you to determine the value of Y. What do you do? Remember, you know the equation of DE. Let's go to the equation of DE. It was this one. Question number, it says the equation of the line DE in the form of this 1.1.3. It was this one. It was this one, the equation of the line. It was this one, yes. DE. It was this, which we also did it as the second one there. So now they're saying here you have got a point G, which is 6, and Y. See, it lies on this equation. So it's a matter of simple substitution here. Where there is X, you put the value of X. Where there is Y, then you calculate. So in here, you're going to say Y is equal to minus 4 over 5, but that X, you put 6 now. You see? Plus 6 over 5. Then to give you the what? That Y value. See that? So you can use a calculator here. And then it was a matter of you substituting. So it's negative 4 over 5. Why? Because when X is 6, what is Y? That's what they're trying to say there. So it lies on that line, and you have to rely on that equation. Alright, so what is the answer? It's minus 18 over 5. Alright, you can write it in decimal point, it's still fine. Alright, so that was that part. Look at the next one. Says the length of DF is equal to DE. Okay, they are telling us the length of DF. Let's look at DF. So this length here is equal to DE. So these are equal. Alright. And then it says what type of triangle is this? What type of triangle is DEF? DEF. Don't know why it's 5 marks, but DEF, like this. What type of triangle? It's an isosceles triangle. I mean, if these two are equal, it's an isosceles triangle. But the 5 marks, maybe they wanted me to find DF and DE. Then let's find the length of DF and the length of DE. Let me use here, because I've got these. Remember the formula for the length? That is what you're using. Let's start with DF. It will be DF is equal to square root of x2. I'm using the same. So x2 is bracket minus 5, and then minus x1, which is minus 1 squared. Very important. Right? Plus y2, which is minus 3, minus y1, which is minus 2, but it's squared. Alright, so here, which is equal to this, will become a plus. So you can use a calculator. The calculator will just solve this for you. You don't have to kind of stress yourself and everything. You just punch this straight away into the calculator, and then it will do everything. So it will be square root of bracket negative 5 minus negative 1. See that? Squared. You can do that, still fine. Plus negative 3 minus 2 squared equal to, say, 41. If you wanted to say, but it doesn't look fine, change that to a plus. See, square root of 41, nothing changes. So this is square root of 41 units. That's the distance. Now that was our DF. Let's find, they say DF and DE. So DF and what was this one? And DE. Point E is 4 minus 2. So let me have point E here. Somewhere here it has 4 negative 2. and they say df, if df is equal to de. Now let's look at de now. Using this point, what will be my de is equal to square root. I'm using the same formula. Now this de, I'll use the second one as my x2 y2, so because I've got already my 1 there, so it will be remember the formula says what? I have that one, x2 minus x1, remember that. So x2, it will be 4 minus x1 minus 1 squared plus y2 is negative 2 minus y1, which is minus 2. Again, put a calculator into this and let it do the work. So it's square root of 4 minus negative 1, or you can put the 2 minus 1 like this, squared, plus negative 2 minus 2 squared. But don't forget, I think I need, I don't know why I'm supposed to open instead like this. Alright, equal to, there it is, square root of 41. So it confirms DE, you see this, DE, DF is equal to DE. And then what type of a triangle? And then they asked you, it's an isosceles, don't think I'm writing it right. It's an isosceles, I think it's like that, triangle. The 5 marks, I think, kind of, it makes me an ease to say, just, I mean, you know what is an isosceles triangle, guys? An isosceles triangle is a triangle with 2 equal sides, you know that. So any triangle, if I'm given A, B, and C, and then if AB is equal to AC, we call that an isosceles triangle. Alright, and then the last one says 1.1.7, the area of triangle DEF. Now, not complicated also. Why? Because they told us the hint that is perpendicular 90 degrees. Remember? And an area like that, you can choose whatever you want to choose. Remember, if I can just give you a normal triangle like this, that's why it's 2 marks. If I can give you a normal triangle like this, alright, and then I say this is 90 degrees, and then what it becomes, this becomes the base, this becomes the height, and area is A is half base times height. Are you seeing that? So it doesn't matter, you can make this the base, you can make this the height. Are you with me? And then they told us, remember, so here it will be, let me write here, area is half base times height, which is equal to half times, what is the base? The base is DE times the height of DF. But they told us DE, remember, DE is equal to DF, which was square root of what? It was square root of 41. Are you seeing? So you can then move on to say equal to 1 over 2 times square root of 41 times square root of 41. Are you seeing that? Then you can simplify this as get the answer now to say what does it equal to. So it will be 1 over 2 times square root of 41 and then times square root of 41, which is equal to what? 41 over 2, which is 20.5. So this is equal to 20.5 what? Units squared. So u squared, you can use that. So that is 1.1.7. So guys, these are the questions that you can expect into this these questions, you know. But now just want to erase these. Then there is 1.2, but look, because of my time, I'm not going to do 1.2, but 1.2 will be a follow-up question. And then watch the second part of the video where they give you the scenario. RQ is what? RQ is parallel to what RQ is RQ. RQ is what, and what RS, SR, RS. I don't know what they wanted to say there, but the coordinates of these, I thought they want to say PS, being parallel there. But anyway, look at this. This is a question that follows. It was out of 32. I want you to check out the next video where I'm going to be looking at question 2. Give me a shout if you want question 2. I will see by your comments on the comments button. Send me your comments. If you don't comment, guys, it means you guys are good. But if you need question 1.2 under this video, just comment that please continue question 1.2. And guys, give me your suggestions, your ideas. If ever you have benefit from this lesson, at least there is an interaction. We've come to the end of the lesson. If you are benefiting, remember to subscribe and don't forget to share this channel with your friends. We've come to the end of our lesson. Thank you.